Hi, everybody. My name is Michael Zeltser. I'm from PayPal. I'm an architect. And today I will be talking about our experience to rebuilding one of the largest systems at PayPal by volume to reactive systems architecture. Okay, a couple of words about PayPal. We are the largest fintech company in the world by now, I believe. Number 51 or 52 at the S&P 500, hopefully household name. And there's a bunch of household names that you might know, Venmo, Zoom, Braintree, etc., which are also part of the PayPal family. All right, so just a couple of words about the business cases we're talking about here. The PayPal, like everybody else, moved to microservices, and with this move came the need to platformize certain horizontal features that everybody is using, and our platform is one of those features. So we started to build this platform about 5-6 years ago, and about a year ago we have completely rebuilt it into reactive systems. So the stuff that it does, it collects tons of signals from different platform services, from different microservices around PayPal. We aggregate them, we process them, we publish them to our analysts, and to provide certain business level analytics about the behavior of the product, which all of this information is used by decision makers to make what we call data-driven decisions about the future investments into products, and just follow up what's going on with PayPal products in general. Okay, and this is the fun part. It is built as a classical pipeline. It collects information through different types of signal collectors that run in each data center and collocate with all the PayPal services. It also collects information from web pages. You know, the PayPal is presented as a checkout button everywhere on merchant sites, and we have mobile clients, mobile wallets, and payment systems and such. So we collect signals from all over the place. We persist our information inside each region. It's an active system. It's distributed all over the place. We then bulk move data to centralized Hadoop cluster, which processes all of the information in one place. We publish it and distribute it across enterprise through different data stores. And finally, as a part of the whole platform and product, we have our own analytical front end with the rich user interface, and which is built as a two-tier system with a query manager and various dashboards and so on. This presentation is built in form of questions and answers, and it's not very technical. I'm not gonna have a tons of code for you to look at. In fact, I only have one code slide. So what I'm trying to do here is to answer the various questions that you might encounter when you start your transition to reactive systems, especially if you work for a large enterprise like ours, and what kind of problems and what kind of decisions you might need to make as it goes. So let me just poll the audience right now. Who here has deployed at least one reactive system in production? Okay, some of you. Who here works for a large public corporation? Some of you, perfect. Who here transitioned from Java to Scala? Many of you, great, okay. So probably not a lot of you here will come as a surprise. So our previous stack looked like this. Fairly traditional, again, our user interface, jQuery, Spring Servlets package, signals collectors. We use, again, Spring Servlet engine. We use Java Chronicle for resilience. For those who don't know, Java Chronicle is the in-memory queues mapped to disk. So if your instance dies, then the queue is preserved and can be bootstrapped back. And our concurrency was managed by Java, just a plain vanilla multi-threading. So in itself, it was not a very bad system. It was maybe slightly reactive, I would say. So we tried to do it as much asynchronicity as possible within it. Intermediate layer of persistence, we use smaller HDFS clusters. Then we use MapReduce in our big data pipe. And we use various data stores we publish to HDFS, Teradata, Elasticsearch, and Druid in memory OLAP system, if you don't know. And so our front end, our own front end worked against Druid. Okay, so it took us about 2 years, I think, to go through all of this and switch to a different stack. This was not done as a one big push. Different portions were replatformed at different times. So the different pieces of system are decoupled, so it was fairly convenient to go piece by piece and deploy it. We started, surprisingly enough, with the user interface. We switched to React.js framework on the browser. I'm not a user experience person, so I don't have a lot to say about it, except that I saw the UI that we have produced, and it looks awesome, and it works real well. So on the back end, the next piece was we started to work with the Akka actors, and S-Cubes is the bootstrapper framework for microservices, which was born at eBay. It's an open source project, and now it's maintained by PayPal, or most of the committers are at PayPal. So we created our query manager using Akka actors. Then we went on and replatformed our signal collectors. So we jumped directly to Akka streams. We kept Java Chronicle. However, we created our framework team who supports the S-Cubes committers, created a wrapper for Akka streams that goes around the Java Chronicle and presents Java Chronicle as a persistent buffer component. If you're interested, you can find it as a part of S-Cubes project on GitHub. So obviously, all of the concurrency and parallelism is managed by Akka streams. All right, so this is about our stack. Let's talk. Let's try to answer the question, what is the necessary skill set to go to this new stack? So now, before that, we were pure Java shop. Right? We did a little bit of development. We started with Spark. Yeah, I didn't mention, right? So the bulk, the big data portion was all Spark. So we use batch. We use both types of streaming. Right now, we're switching to structural streaming, but most of the use cases are still on the Spark batch. So we used to be Java shop before Spark showed up. That kind of opened up our eyes to the world of Scala. We looked around and decided that the Scala world and the whole reactive scene was pretty good fit for us. So we started to look seriously at this direction. Over all of the time that we've been replatforming our project, we did not hire specifically Scala developers. We hired lots of people, but we did not hire anybody with the Scala set. So everything was education, internal education, and rethinking all the concepts and basically training and all from the inside and with the help with the our S-Cubes people who were very well versed in Scala and Akka already. Okay, so the first step, and we believe this is a pretty important step, is to get your head out of the imperative programming world. So we decided that maintaining state and dealing with side effects and all other things that come with the normal Java development are not very good for making systems reactive. So we re-educated ourselves first to just general conventional functional programming, and then we added functional reactive programming on top of it. So that was our first step, all the futures and promises and so on. Often I get the question, is it really necessary to jump to Scala? And the answer is, technically speaking, it's not necessary. We have different teams at PayPal. Some of them, I've heard, just recently started to switch to Akka, still using Java. However, from my personal experience and the experience of this project, what we saw is that it is very hard to take developer out of the imperative world of view, out of the changing and sharing state and synchronizing state and so on, if you stay with Java. So we went to basically to the max and decided that, hey, we gotta switch the brain first. And in order to switch the brain, we need to help, and we need a good language to support the switch, and the Scala happens to be a pretty good one for that reason. And for those who don't know, if you want to go all immutable and functional, in theory, you can try to do it in Java 8, and maybe you can wait for Java 9. But if you go to Scala, the whole equation is kind of reversed, right? So you have to work hard to do imperative state-changing code, and all the data structures out of the box are immutable, and so all the efficiency is already there. The next step, obviously, you need to decide, well, your concurrency thing. So this came kind of naturally, right? You don't want to stay with the multi-threading if you have actors framework. So there's a couple of reasons for that. The first and foremost reason is that the efficiency of managing threads are much higher if you follow the actor systems and actors approach, right? So yes, there's a cost, all this messaging, passing, etc. But as far as I can tell, this is probably one or only maybe a handful of ways to go really asynchronous and reactive these days is to use actors framework. And the Akka is probably the leading library out there. If you don't know anything about actors, we have a little blog on our engineering blog site at PayPal that basically like 10 minutes explain actors basics. You can educate yourself. So the next kind of a larger step, of course, the actor switch to actors was natural, right? If you go Scala, if you look at the whole reactive community, this is what you get, right? But the next step, and to go to streams, right? So is this really necessary? Again, streams concept, reactive streams concept, back-pressured stream concept is fairly new on the scene. So the answer to this question, you don't have to. You can stay with actors. However, what we have learned, because we started with just a pure actor application, is that if you worry about ratio between your business logic and all kind of ceremonies around, say, managing the workload, or managing the errors, and just managing exchange of messages between different actors, right? So you get into the, if you want to create a really scalable application that works for our streaming-like use case, you get into the world that you spend more and more time doing something else than your core business logic. And so Akka, out of the box, provides lots of pool allocation components. You can broadcast to a bunch of actors. You can maintain the pools, and all that stuff is nice. Still, it's a little bit too much and not really necessary if you already have a stream API out there. So for the signal collectors, we decided that the stream is the way to go, and we jumped into it directly. So now, there was a couple of things that we had to add. For example, we had to add the wrapper for Java Chronicle and so on, but that was a small price to pay. And of course, the Kafka is supported by Alpaca project. We use that library to connect our streams to Kafka. The last question, okay, which bootstrapper for Akka you need? So Akka is a library. You need something to run your service, actually. So there's a couple of options, I believe, out there. The Play is the main one, and S-Cubes is less known. S-Cubes is a very thin layer that the only thing it does is microservices. There's nothing else. If you want something else with the UI support, whatever, then Play probably a better option. But we found that S-Cubes is very lightweight and easy to deploy. And of course, there's a benefit. It's supported by PayPal itself. So we kind of got lucky on this one. All right, so this is the skill set you have to go through. All right, so the next question is, I think not asked often enough. Especially if you're part of a large company, you probably will hear it more and more. What is the business motivation, right? How do you explain to your decision makers that responsible for giving you a budget that you want to spend maybe a year or maybe 2, depending on the complexity and size of your system, just rewriting the whole guts of your system just because, right? So we as a technical people often come to the decision makers and say, hey, this is the cool technology. It's great. Okay, let's do it. And then people are looking at us like crazy people. And well, how much it will cost and what it will give us, et cetera. So that's one question. The second question, how much risk can we take? I mean, what if it's not going to work, and so on and so on. So on this one, so let's talk about risk first, right? So the area that my platform sits in is somewhere in this second circle, which is core platform services, which is important systems, but not critical to the point that you cannot take any risk at all. Right? So our core platform systems at PayPal obviously are payment systems. We deal with money. If we are down for a second, we lose maybe millions of dollars, I don't know, but a lot, and there's a lot of aggravation. So it is very hard to go convince people to take a huge chance and start monkeying around with your core business, right? So we got lucky. My platform is sitting on this somewhere here, and the price of the system is surprisingly higher than the price of the core platforms, or typical core platform, because of the volume of the data that we collect. Financial transactions are fairly compact, so there's not much data flowing through the system in terms of the size of it. We collect all kind of instrumentation from all kind of different systems, which, like I said, there's about 2K per event, and there's a 20 billion event. That's a lot of stuff. So on one hand, you have about medium risk for change, risk tolerance for change, and relatively high cost. right? So this is the perfect sweet spot for you to go and start discussing decreasing cost, increasing efficiency, and even if the risk is there, still good deal. Okay, so the second part is actual money, right? So let's look at this. So our platform, so the dark green line is our volumes. So the volumes in our platform raising really high, really hard. It's about doubling every year. So the reason is the whole move from monolith products to microservices is that all of the traffic that used to be hidden somewhere in monolith, which people did not realize exist, now falling on us. And as the company transforms itself, we get this crazy adoption cycles every year. The second part of it, like I said, it's decision makers are very hungry for the data these days, right? So this is the new way of doing business. Nobody wants to follow the intuition. Everybody wants to follow the data. So comparing to volumes, our old platform, right? The compute, and I'm concentrating on compute here because there's nothing you can do about storage really using reactive systems, right? This is a different things. I'm not talking about that. Only compute pretty much. So our hardware allocation, and if you work for a large American company which is service-oriented, you know, like before the holidays, you have those discussions, how we're going to survive the holidays, right? You're going to look at your pools and we have an internal cloud within PayPal. Size of the pool, you measure your traffic, et cetera. We have predictions based on the last year and so on. And we get to say, okay, we need to double our size of our pools or something like that. So we usually increase our pools before holidays about this time of year by 80, 90%, right? So this is the light green line. So it's not really doubling because even in the old platform, we were trying to get our efficiency, trying to remove the bottlenecks and so on as hard as we could. So now, so this is the numbers from the last year, right? So this is our basically our volumes and corresponding compute from the last holiday season. So this year, we started to roll out our reactive version about right after the last holiday season, so about January timeframe. So by the April, we were kind of done, and especially on the signal collectors, we were done by April for sure, and the rest of the system were in production since August or something like that. Okay, so we're sitting this time around and looking at our predicted volumes this year, which last year was about 11, at peak 11 billion signals, and this year we're predicting around 20 billion signals per day. And we're looking at our hardware usage and allocations, and we're seeing that we don't need to increase our pools this year. We keep it at last year, and even that is too much. We probably have to decrease it, but we decided we're not going to risk it before holidays. We're just going to keep it as is. And our prognosis for next year, according to this, is probably we'll keep it at a flat level for another doubling. So this is pure money right there, right? So this $2 signs I scratched out. Our system went down on the compute side especially. So that was expected for insiders, of course. We know that's what's supposed to happen when you switch to Akka, and especially when you switch to streams. But for the larger community, it was really a good shock. Okay. All right, so that's enough about dollars. So the next question you want to answer when you go reactive is which use case to pick. Now again, we sort of stumbled into it because we had a streaming use case, and this is how it happens. And the streaming use case in using this graph like this was just perfect for us. But you really need to think about it, what you do, right? I believe the streaming can be fit to work with a bunch of stuff. I mean, obviously, Internet of Things. This is pretty much how you do it. Our stuff is instrumentation and logging. This is how you do it. Just the common application logging. This is how you do it. There's probably a bunch of other things I just haven't thought about those. All can be retrofitted to work as a stream. So in our case, what we do is we build end-to-end back-pressured stream, right? So at the entry point, we have unbounded HTTP stream, right? So the Akka HTTP is the stream, right? For those who don't know, Akka HTTP is implemented on top of the Akka Stream API. So basically, you define your flows, which is become part of your graph, and you say, okay, your flow is supposed to accept HTTP request on the inlet, and this is how the Akka HTTP works these days. And on the outlet, it's supposed to be HTTP response. Okay, so our business logic is all encapsulated inside long-lived streams, and well, the long-lived streams, I don't remember if it's a part of the actual Akka or this is S-Cube's notion. I think it's a part of the lifecycle management of the streams that S-Cube's teams provided to us. So we put our business logic somewhere here, which is some transformation, some cleanup, et cetera, enrichment. And then how do you connect your HTTP to your long-lived stream? Now, HTTP is the stream that only lives in the duration of HTTP request, which in our case is fire and forget, is very short duration. And a long-lived stream basically bootstrapped when the service starts, and then it shut down when the service either crashes or just shut down. And so to connect all of those multiple streams that are created each time that there is HTTP connection, we used the merge hub component, which is part of the Akka streams, which allows you to have this connection established in runtime, right? After all the streams are materialized, okay? And so the code to do the connection is basically what's highlighted here, right? This is the only line that you need to connect those two streams. Everything else is, the previous lines is we just extract an event from the HTTP request payload. And like I said, it's fire and forget. So once we pass a message to the long-lived stream, we just close the HTTP by passing back the HTTP response code with OK. All right. So what happens here, for those of you who are familiar with how the back pressure works across the stream, so this is end-to-end back pressure, right? So the outlet is, after we do some enrichment, we push stuff to Kafka. Now, there's an interesting effect happens here. If our Kafka slows down or something happens on this side, the back pressure goes all the way to your HTTP, which is sort of surprising, cool, but surprising. So, which means that the HTTP will start rejecting new requests if your Kafka all over here is pushing back pressure back to you, right? So that's not something that we do. We actually have a buffer in between here that accepts all the flow that we can get, and this is where the Java Chronicle comes to play. If you want a little bit more details on this one, there is again blog post on the PayPal engineering blog that is done by developer of this system. So you can take a look how this is implemented. Okay, but this is probably the best use case to start with if you want to go reactive. Another use case is a little bit more convoluted, but again, it's fairly typical. And I would define it as query mediation. So if on one, how do I say it? If both sides of your mediation process are asynchronous, now your middle is better be able to handle asynchronous interactions, right? So you have people, human beings on one side, we have a distributed database on the other side, and our Druid is distributed across multiple data centers, so it's very distributed. And inevitably, what's happening is that when Druid gets a little bit funky, this whole thing become upset because people get, clicking, refreshing, closing browsers, opening browsers, and stuff like that. Okay, so what you need here is to manage time, and this is what the functional reactive programming is for, right? All the futures and stuff. All of the watch faces indicates the points where you need to manage your time, you need to manage your timeouts, everything needs to be asynchronous, you need to watch out for or identify repeated requests, right? You need to put them in sort of a queue, wait for the answer to come that probably serve a bunch of those requests at the same time. There's a lots of this activity, right? I don't know about you guys, but personally, when I start thinking about all of this in the terms of Java multi-threading, my brain become broken immediately. If I start thinking about this, even just plain futures, still I cannot reason about this. But if I put actors in place, and the actors, when you design stuff in actor systems, this is you can use what I call anthropomorphic design. You can imagine and reason about the behavior of your system as it is human beings interacting with each other by sending emails to each other. It's very helpful. So when you put actors as a proxies for your actual users and maybe as a proxies for actual Druid queries, right? The things become kind of manageable to imagine and to reason about. And you add futures as kind of a triggers, as opposed to in a classical FRP, right? You put a bunch of business logic inside futures, and you have chaining of futures, and you have the composable futures. My head hurts already. So the way we do it, we use actors to hold the business logic, and we use futures as sort of a triggers to manage the timeouts. So that works real nice. And it's still complicated, but it's not as complicated as in any other case. Okay, so this is another pretty good use case. All right, so this is the couple of last slides just to bring everything together. So a little reverse engineering of the whole process, how we got into this mess to begin with. So I got it separated to three phases. The one is kind of evolution or implicit adoption or just stumbling around. So what I advise is look around. You probably will find the reactive systems already in your enterprise or in your company. These days, best breed of products, usually reactive systems like Spark for sure, React, whatever, Druid, maybe Kafka, kind of. And so on, right? So this is how we got into the whole thing, right? So we just learned from Spark and so on. I strongly advise to get off the whole Java bandwagon and go into new paradigm and functional programming, etc. Especially take care of your mutable state. Clearly, seek mentors. I mean, functional programming community is very, very active and very excitable, so they're always ready to jump and help you. And this is what happened to us, right? I found just some group. PayPal is a huge company, for those who don't know, about 20,000 people, so it's not that easy to find people that can help you. So I found some Scala group, somebody who's talking about functional programming. And they happen to be the committers for the S-cubes, and they helped us a lot and educated us a lot, and so on. SelfEducate, so personal experience. Took a bunch of courses on Coursera from the creator of Scala. Keep forgetting his name, but you know him. So yeah. The second part, so now you understand what's this all about. You can convince yourself this is the good stuff, right? So now you have to go and convince the other people around it and push it through. Yeah, so the first step is convince your boss, right? So the money talks, right? It's just don't talk about cool stuff. Just talk about money first, right? That really gets you there. The second part is, surprisingly, I had to work hard to convince the team, because despite the fact that they like cool stuff, I mean, if you imagine, do your job and learn new things, and then do the stuff in using new system is like working at two workplaces at the same time. You have to do double work, maintain the old stuff and do new. But still, cool is always cool, and Reactive, I think, today is as cool as it gets. So Educate, with the help of the other people, I've done lots of quick start little projects that maybe takes a couple hours to go through, and I repeated it incessantly, maybe once a month, once a quarter, and so on, until people got really, really comfortable with the whole thing. Choose carefully which use case you go to, right? So the best way, if you get both those criteria together, hard to do using conventional means. That's the example with a query mediation between two asynchronous sites. It's really hard to do if you're just running Java multi-threading. And the clear efficiency gain, as in case of streaming, of course, that's the best. And hold hands. This is another surprising revelation, right? So after all of the education, all of the stuff that we did, everybody on board, everybody excited, everybody's writing this stuff, you need to watch out the code. I found a bunch of places that people started to use mutable collection without absolutely no reasons, just because they think like this. They started to use for loops without any reason whatsoever. And the funniest one, they used the weight inside the actor system to just collect the whole thing in the one place, which was kind of crazy. Anyway, so in the first year, I have reviewed every single line of the code that my team has written. All right, and so this is the final slide, and you can all go home. We are in the phase 3 right now, right? We call it new normal. So now, what we still is just one of maybe 3 teams at PayPal that does this. So it's very important to keep this to keep it going, right? And I keep going back to the money portion, right? So you know how in casinos you always hear the money noises coming out from all the places, even there's no cash anymore in casinos, right? I don't know, in Canada, I haven't visited a casino here, but I think this is the same here. So like in Vegas. So make noises, right? So the amount of capital CapEx and OpEx we have saved this year for our company is in millions of dollars. So this is pretty cool. Share and educate, spread the virus, right? Some people did it for us and so pay it forward essentially. And the most important one at this point is, if you already deployed your system, right, stop explaining why. You know, people keep coming to you. Why do you need this? Why do you do this? Why all this hassle? So I just stopped. Now I'm just asking why not, and that is it. Okay, I'm done. Questions?
For Druid, when you guys went to Druid,
yeah.
It looks like that was in your kind of your legacy stack before. Did you guys have an easy experience with that, or what was it like to do the conversion? I'm assuming you came off of Teradata.
So yeah, so Druid, right? So how do I explain this? So it's still ongoing process, right? It's not, the story is not finished. We still have tons of users on Teradata. And Druid was at first experimental, and we had to work with the Druid team a lot. We were, I don't know, we may be one of the biggest customers or users of the Druid, right? And we keep finding certain things, especially, you know, there's metrics that you try to estimate instead of calculate. Those things did not really work well for us, right? That's one of the things. But other than that, it is surprisingly working well, right? Like I said, this year we spread into the multiple data centers deployment, which went without a problem. We didn't even notice, right? So that was interesting in terms of system deployment and so on. There's new tools coming online from the Druid people, which create a very good transparency for the Druid cluster itself. This is one of the things to watch out. It's not really, it's hard to, so when you grow your cluster, some nodes are disappearing and then reappearing, and they're not attached to the proper groups. We have like groups within the Druid for different use cases, something to watch out to. So monitoring and all that stuff, it's all almost there, okay? You cannot, I mean, maturity level, you cannot compare with Teradata, obviously, right? But Teradata is so expensive that, well, it's worth it. Yes?
Thank you very much for talk. How the troubleshooting, testing, and development process changed for guys in the team?
Right.
Because it's different.
It's a great question. So testability of our system has increased by far. First of all, our code base has been reduced probably, I don't know, 1,000 to 1, right? So the actual code that we use in our streaming applications is so tiny. It's just, okay, what happens with all the thousands of lines, right, that we used to have before? And obviously, there is the testing. You get the flow, you put it in scaffolding between two ends, and you test it. This is it. So we had maybe 2 major bugs that took us time to follow through, mostly because the HTTP, Akka HTTP has a more strict enforcement of certain things in HTTP protocol, and we were lax before, and we kind of figured out, oh boy, we were lax. So now we don't get any messages from this guy and from that guy. So those type of things we caught early in the process. Performance testing, well, we just put it in the same kind of arrangement we do for all PayPal applications. So I cannot really compare. It's the same. I mean, our S-cubes that we use has all the JMX hookups, etc., so we can watch what's going on. So that wasn't a problem. Yeah, so I would say testability is a huge improvement. All right, we're done. Thank you.